How AI Ate My Website. What do most people picture with that title, AI Eating a Website? They might perhaps imagine some scary things, like a giant computer brain eating up web pages on its way to global dominance. Ah, my poor little guys. Don't worry, they'll be back. In truth, though, most people today probably think of AI as something more like ChatGPT, the popular large language model from OpenAI. These kinds of AI models are trained on huge amounts of data, including sites like mine, which gives them the ability to answer questions such as, "Who is Luke?" ChatGPT does a pretty good job, so I guess I don't need an intro slide in my presentations anymore. But it's not just my site that's part of these massive training sets. And since large language models are essentially predicting the next token in a sequence, they can easily predict very likely, but incorrect answers. For instance, it's quite likely a product designer like me went to CMU, but I did not, even though ChatGPT keeps insisting that I did, in this case for a master's degree. No problem though, because of reinforcement learning, many large language models are tuned to please us, so correct them and they'll comply or veer off into weird spaces. Let's zoom out to see this relationship between large language models and websites. A website like mine, including many others, has lots of text. That text gets used as training data for these immense auto-completion machines, like ChatGPT. That's how it gets the ability to create the kinds of responses we just looked at. This whole idea of training giant machine brains on the totality of published content on the internet can lead people to conjure scary AI narratives. But thinking in terms of a monolithic AI brain isn't that helpful to understanding AI capabilities and how they can help us. While ChatGPT is an AI model, it's just one kind, a large language model. There's lots of different AI models that can be used for different tasks, like language operations, vision operations, and more. Some models do more than one task, others are more specialized. What's very different from a few years ago, though, is that general-purpose models, ones that can do a lot of different tasks, are now widely available and effectively free. We can use these AI models to rethink what's possible when people interact with our websites, to enable experiences that were impossible before, to go from scary AI thing to awesome new capabilities, and hopefully make the web cool again, because right now, sorry, it's not very cool. With that in mind, I want to show you how we used a bunch of AI capabilities to create a new way of using my personal website, lukew.com. I started this site 28 years ago. Yeah, I'm old. And over the years, I added lots of content, specifically 2,000 text articles, 100 plus videos, 300 PDF presentations, and lots more. To make their way through all this content, God bless them, people basically have two options. They can search or browse. But given we're talking about 500,000 written words, 6,000 minutes of video, 3,000 minutes of audio, that's a lot to wade through to get to what you're looking for. In the real world, if you have a question for me, like, how do I decide which metrics to use for my app? You can simply ask. And I'd go, let me think about what I know, remember a bunch of things, and assemble an answer. All in my head. The human brain is a pretty amazing thing. That real-world experience is quite different from our options online. We can use keywords to get search results to comb through, or browse through pages of links for what we need. But what if instead we could get closer to the way I'd answer your question in real life? That is, I'd go through all the things I've written or said on the topic, pull them together into a coherent reply, and even cite the sources so you can go deeper, get more context, or just verify what I said. In this case, part of my response to this question comes from a video of a presentation just like this one, but called Mind the Gap. If you select that presentation, you're taken to the point in the video where this topic comes up. Note the scrubber under the video player. You can search or ask questions of just this video. The summary, transcript, topics, speaker diarization, and more are all AI generated. More on that later, but essentially, this is what happens when a bunch of AI models effectively eat all the pieces of content that make up my site and spit out a very different interaction model. Now, the first question people have about this is how? How was this put together? But let's first look at what the experience is and then dig into how it gets put together. When seeing this, some of you may be thinking, I ask a question, you respond with an answer? Isn't that just a chatbot? Chatbot patterns are very familiar to all of us because we spend way too much time in our messaging apps. The most common design layout of these apps is a series of alternating messages. I say something, someone replies, and on it goes. If a message is long, space for it grows in the UI, sometimes even taking up a full screen. Perhaps unsurprisingly, it turns out this design pattern isn't optimal for iterative conversations with sets of documents, like we're dealing with here. In a recent set of usability studies of LLM-based chat experiences, the Nielsen-Norman group found a bunch of issues with this interaction pattern, in particular with people's need to scroll long conversation threads to find and extract relevant information. As they called out, this behavior is a significant point of friction, which we observed with all study participants. To account for this, and a few additional considerations, we made use of a different interaction model, instead of the chatbot pattern. Through a series of design explorations, we iterated to something that looks a little bit more like this. In this approach, previous question and answer pairs are collapsed, with a visible question and part of its answer. This enables quick scanning to find relevant content, so no more scrolling massive walls of text. Each question and answer pair can be expanded to see the full response, which, as we saw earlier, can run long due to the kinds of questions being asked. Here's how things look on a large screen. The most recent question and answer is expanded by default, but you can quickly scan prior questions, find what you need, and then expand those as well. Net-net, this interaction works a little bit more like a FAQ pattern than a chatbot pattern, which kind of makes sense when you think about it. The Q&A process is pretty similar to a help FAQ. Have a question, get an answer. It's a nice example of how starting with the problem space, not the solution, is useful. I bring this up because too often designers start the design process with something like a competitive audit, where they look at what other companies are doing and, whether intentionally or not, end up copying it, instead of letting the problem space guide the solution. In this case, starting with understanding the problem versus looking at solutions got us to more of a FAQ thing than a chatbot thing. So now we have an expandable conversational interface that collapses and extends to make finding relevant answers much easier. But there's something missing in this screenshot, and that's suggested questions. For the purpose of this presentation, I simplified the UI a bit in the past few examples. But on the real site, each answer also includes a series of suggested questions. The first few of these are related to the question you just asked, and additional ones come from the rest of the corpus of content. These are pretty critical because they address the issue of, what should I ask? And it turns out lots of people have that problem because a very large percent of all the questions asked kick off with one of these suggestions. We knew from the start these were important, but it took a bit to get to the design solution you see here. At first, we experimented with an explicit action to trigger suggested questions. Need an idea for what to ask? Just hit the light bulb icon. We then iterated to a more clear, what can I ask link and icon that works the same way. But in both cases, the burden was on the user to ask for suggested questions. So we began exploring a series of designs that put suggested questions directly after each answer, automatically. With this approach, there is no work required on the part of the user to show suggested questions. These iterations continued until we got to suggested questions directly in line in our expandable conversational interface. Now, as I mentioned, answers stem from finding the most relevant parts of documents, stitching them together, and citing those replies. You can see one of these citations in this example. It also serves as an entry point into a deeper, object-specific experience. Now, what does that mean? Well, when you see these cited sources, you can tap into any one of them to access the content. But instead of just linking out to a separate window or page, which is pretty common, we tried to create a unified way of exploring each one. Not only do you get an expanded view into the document, but you also get document-specific interactions and the ability to ask additional questions scoped just to that open document. Here's how that looks, in this case for an article. You can select the citation to get the full experience, which includes a summary, the topics in the article, and again, the ability to ask questions just of that document. In this case, about evolving e-commerce checkout. There's more document types than just web pages, though. Videos, podcasts, PDFs, images, and more. So let's look at some of these object types and see how we can break them down using AI models in a way that can then be reassembled into the Q&A interface we just saw. Now we're getting more into the how does this work versus the what is this? For each video file, we first need to turn the audio into written text. For that, we use a speech-to-text AI model. Next, we need to break that transcript down into speakers. For that, we use a diarization model. Finally, a large language model allows us to make a summary, extract keyword topics, and generate a list of questions each video can answer. We also explored models for identifying objects and faces, but don't use them here. But we did put together a custom model for one thing, keyframe selection. There's also a processing step that I'll get to in a bit. But first, let's look at this keyframe selection use case. We needed to pick out good thumbnails for each video to put into the user interface. Rather than manually viewing each video and selecting a specific keyframe for the thumbnail, we grabbed a bunch automatically, then quickly trained a model by providing examples of good results. Show the speaker, eyes open, no stupid grin. In this case, you can see it nailed the which Paris girl are you backdrop, but left a little dumb grin. So, not perfect. But this is a quick example of how you can really think about having AI models do a lot of things for you. If you can model the behavior, you can probably train a machine to do it at scale. In this case, we took an existing model and just fine-tuned it with a smaller number of examples to create a useful thumbnail picker. In addition to video files, we also have a lot of audio, podcasts, interviews, and so on. Lots of similar AI tasks to video files. But here I want to discuss the processing step on the right. There's a lot of cleanup work that goes into making sure our AI-generated content is reliable enough to be used in citations and key parts of the product experience. We make sure proper nouns align, aka Luke is Luke. We attach metadata that we have about the files, date, type, location, and break it all down into meaningful chunks that can be then used to assemble our responses. The same thing happens for web pages. But when we have all these cleaned up bits of content, how do we get the right ones to assemble a useful answer to someone's question? Well, all those chunks of content get mapped to a multi-dimensional vector space that puts related bits of information together. So things that are mobile touch-ish end up in one area, and things that are e-commerce-ish end up closer to another area. This is a pretty big simplification, but it's a useful way of thinking about what's happening. So let's enter the obligatory system diagram. The docs that we have, videos, audios, web pages, get cleaned up and mapped to parts of that embedding index. When someone asks a question, we retrieve the most relevant parts, rank them, sometimes a few times, put it together for an AI language model to summarize in the shape of an answer. And sometimes we even get multiple answers and rank the best one before showing it to anybody. Feedback is also a really important part of this, and why kind of starting with something that roughly works and iterating is more important than doing it exactly right the first time. So what's the impact of doing all this versus just using something like ChatGPT to ask questions? Well, for starters, you get very different kinds of answers, much more focused and reflecting a particular point of view versus general world knowledge. As you can see in the difference between a ChatGPT answer on the left to why do designs look the same versus the answer you get from Ask Luke. On the Ask Luke side, you also get citations, which allow us to do a bunch of additional things, like object-specific experiences. On Ask Luke, you ask a question, get an answer with citations to videos, audio files, web pages, PDFs, etc. Each one has a unified but document type specific interface. The video experience, for example, has an inline player, a scrubber with a real-time transcript, the ability to search that transcript, some auto-generated topics, summaries, and the ability to ask questions just of what's in the video. When you search within the transcript, you can also jump directly to that part of the video in the inline player. Audio works the same way, just an audio player instead of a video screen. Here you can see the diarization and cleanup work at play, which is how we have the conversation broken down by speakers and their names and the timestamp for the transcript. Web pages have a reader view, just like videos and audio files. We show a summary, key topics, give people the ability to ask questions scoped to that article, and by now you get the pattern. So PDFs are mostly the same, just a PDF reader instead of a video player, etc. However, PDFs are special in another way, as in painfully special. Let's look at what happened to our answers when we added 370 plus PDFs to our embedding index. On the left is an answer to the question, what is design? Pretty good response and sourced from a bunch of web pages. When PDFs got added to the index, the response to this question changed a lot, and not in a way that I liked. But more importantly, only one PDF was cited as a source instead of multiple web pages. So what happened? What happened is a great demonstration of the importance of the document processing, aka cleanup step, I emphasized before. This ugly spreadsheet shows the ugly truth of PDFs. They have a ton of layout markup to achieve their good looks. But when breaking them down, you can easily end up with a bunch of bad content chunks like the ones here. After scoring all our content embeddings, we were able to get rid of a bunch that were effectively junk and clogging up our answers. Removing those now gives a much better balance of PDFs, videos, podcasts, and web pages, all of which get cited in the answer to what is design. More importantly, however, the answer itself actually got better. Hopefully, you now have a sense of what it takes to make a system that eats all this content, all 28 years worth, and reforms it in new ways. Ways that make use of a variety of AI models for language operations, vision operations, and more. Hence all my little AI guys hustling to do work behind the scenes to make all this happen. The end result is not a scary AI thing, but instead, a new way to make use of the 28 years worth of content I've published. So I'll end with a meta slide. Let's use all this designer-made AI to ask it what designers should do about AI. That answer seems pretty good to me. So I'll end with a meta slide. Let's use all this designer-made AI to ask it what designers should do about AI. Looking over the answer, looks pretty good to me. On behalf of me and all my little AI guys, thanks. You can play with everything I showed you at askluke.com.